Okay, so today, let's take a deep dive into something pretty crucial for the oil industry, and honestly, it has ripple effects, on the global economy. Accurate oil reserve estimation. It's more complicated than you might think.
Yeah, you're absolutely right. Getting those estimations right impacts investment decisions, production strategies, even international relations when you think about it.
Definitely, and one of the key factors in figuring out just how much oil we can actually recover from a reservoir is something called bubble point pressure, or PB. So today we're looking at some new research from Energies that, well, it uses machine learning to predict PB with incredible accuracy, I gotta say.
Yeah, this is cutting edge stuff, really pushing the boundaries of what we thought was possible.
So for our listener who might not be, knee deep in oil production every day, what exactly is bubble point pressure?
Okay, so imagine an oil reservoir deep underground. It's not just a pool of liquid, right? The oil has gas dissolved in it, kind of like how a soda bottle has carbonation. Now, as you start to pump the oil out, the pressure in the reservoir drops, obviously. And at a certain point, the pressure gets so low that the gas can no longer stay dissolved. So it starts to form bubbles. And that critical pressure point, that's the bubble point pressure.
Interesting. So it's like the tipping point where the oil well goes from producing mostly oil to producing a mixture of oil and gas.
Exactly. And knowing that point is essential for all sorts of things. For example, if you know the PB, you can more accurately estimate how much oil is actually recoverable from the reservoir. And it also impacts the design and operation of the equipment needed to, extract and process the oil.
Okay, that makes sense. So how have we been figuring out this bubble point pressure in the past, and why is this new research such a big deal?
Well, traditionally, we've relied on empirical correlations, basically equations developed, based on observed data. But the problem is these correlations were often developed using limited data sets, sometimes even specific to particular types of oil.
But wouldn't that make them less accurate when applied to a broader range of oils from around the world?
That's the issue. Crude oil from, say, the North Sea can have very different properties than oil from the Middle East or Africa. So a correlation that works well in one region might be way off in another.
So these researchers decided to tackle this problem by, going big on the data, right?
They went massive. Their study used a machine learning model, something called a least squares gradient boosting ensemble, LS-boost for short, and trained it on a global data set of, get this, 4,800 pressure volume temperature, or PVT, measurements. That means they had data from oil fields across the North Sea, Africa, Asia, the Middle East, and North and South America.
Wow. That's incredibly comprehensive. They weren't messing around.
Not at all. And to make sure this wasn't just a fluke, they didn't stop there.
Oh. What else did they do?
They tested their model on a completely separate and independent data set of 775 PVT measurements, data the model had never seen before. It was like a final exam, right, to see how well it could generalize its knowledge to new scenarios.
That's a pretty rigorous test. So how did LS Boost do? Did it pass?
It aced it.
Give us the details.
Okay, so on that massive global data set, the LS-Boost model significantly outperformed 13 existing PB correlations. We're talking about a mean absolute percentage error, or MAPE, of just 7.57%. That's really low. Even on the independent data set, it still performed remarkably well, with a MAPE of 9.3%.
Wait, hold on. For our listener who might not be as familiar with these statistical measures, what does that MAPE number actually tell us?
It essentially tells you, like, how far off the predictions are, on average. So a MAPE of 7.57% means the model's predictions were, on average, only off by about 7.57%.
That's impressive, especially when you consider, the complexity of these oil reservoirs.
Absolutely. And the study also highlighted how some existing correlations performed particularly poorly on certain types of crude oil, like African crude oils, where one correlation had a MAPE of over 28%. The LS-Boost model, however, achieved a MAPE of just 10% on the same crude type.
So not only is it more accurate overall, but it's also better at handling those, trickier types of oil that have been historically difficult to predict. This seems like it could be a game changer for the industry.
It has the potential to be, but we should dig into exactly how this impacts oil production and why getting these PB predictions right is so important in the real world.
Let's do it. This is where things get really interesting.
It's not just about numbers on a spreadsheet, and it's not just about efficiency, right? Getting these predictions right could also lead to more sustainable oil production.
That's a good point. Yeah. If we can, more accurately estimate how much oil is recoverable and optimize production accordingly, we can minimize waste and potentially reduce the environmental impact of oil extraction. It's about being smarter with how we manage this resource, right?
Precisely. And this research also, raises some interesting questions about the broader applications of machine learning in other industries. It's not just about oil,
That's what I find so fascinating about these deep dives. We start with a specific topic, but then end up exploring these much bigger ideas.
This study is a great example of that. It highlights how machine learning, powered by vast and diverse data sets, it can unlock insights that were previously hidden.
So it's not just about the technology itself, but the way it changes how we approach, problem solving.
Right, we're moving away from relying solely on traditional methods and embracing the power of data-driven approaches.
Think about the possibilities. Could we use similar techniques to, predict weather patterns with greater accuracy?
That's a fantastic example. Imagine the impact on agriculture, transportation, disaster preparedness if we could get even more precise weather forecasts, right?
Or what about predicting equipment failures in manufacturing plants before they happen?
Oh, think of the cost savings and increased efficiency if we could anticipate those breakdowns and address them proactively.
It seems like the potential applications are limitless, but this also makes me wonder, are there any downsides to relying so heavily on these machine learning models? I mean, they're built by humans, right? Couldn't there be biases baked into the algorithms?
That's a really important point and a valid concern. Any model is only as good as the data it's trained on. And if that data reflects, existing biases or limitations, the model will inherit those flaws.
So it's not just about blindly trusting the output of these models. We need to be aware of their limitations and always approach the results with a critical eye.
Exactly. We need to be asking questions like, where did this data come from? What are the potential biases it might contain? How was the model trained and validated? All those important questions.
So it's a powerful tool, but it's not a magic bullet.
That's a great way to put it. And it brings us back to the core of what we're trying to do here with the deep dive.
It's not just about summarizing research findings, but about prompting our listener to think critically about these issues.
To understand the potential, but also the limitations. And to ask those tough questions that help us, move forward in a responsible and informed way.
And for our listener out there, what are some of the key takeaways you think they should walk away with today? What's the so what of all this?
I think the biggest takeaway is the sheer power of machine learning when applied to, complex problems. This research demonstrates that with the right data and the right approach, we can achieve levels of accuracy and insight that were once thought to be impossible.
And that has implications that go far beyond just the oil industry.
Absolutely. This is about unlocking new possibilities across a wide range of fields, from healthcare to finance to climate science.
But it's also crucial to remember that that machine learning is a tool, and like any tool, it can be used for good or for ill.
That's why it's so important to be informed, to be critical, and to engage in these conversations about the ethical implications of this technology.
We can't just passively accept the outputs of these models. We need to be active participants in shaping how this technology is developed and deployed.
This is where our listener comes in. What industries are you passionate about? What are the big challenges that need solving? How could machine learning play a role? And what are the potential pitfalls we need to be aware of?
Those are the questions we want you to grapple with. So we've only just scratched the surface here, but hopefully this deep dive has given you some, food for thought.
And maybe even spark some ideas about how you could, apply these concepts in your own field, whatever that may be.
This is what makes exploring these research topics so excited for me. It's not just about learning something new. It's about realizing the potential impact it could have on the world.
I completely agree. And I think the research we discussed today, it offers a glimpse into a future where data-driven insights are transforming industries in profound ways.
Imagine a world where we can predict and manage complex systems with a level of precision we never thought possible. But that also comes with a responsibility, right? To use this power ethically and thoughtfully.
That's a crucial point. As we embrace the power of machine learning, we need to be mindful of its, limitations and potential biases. It's not a silver bullet. But like we were saying before, it's a tool that requires careful consideration and critical thinking.
So to our listener, we leave you with this challenge. Don't just be a consumer of information. Be an active participant in shaping how this technology is used. Ask questions, challenge assumptions, and think critically about the ethical implications.
The future is being written right now, and we all have a role to play in ensuring that it's a future we can be proud of.
Well, it's been another fascinating deep dive. Always a pleasure exploring these cutting-edge topics with you.
Until next time.